All right, so first things first, look at page 26. Son of a biscuit. I feel like this is like a daily occurrence. Yeah, because my Chromecast hates me. Okay. All right, so okay, so I actually want to do a problem from your homework yesterday. So look at on page 28, look at number 17. All right. So yesterday we talked about vertex form. So remember, vertex form gives you what key feature right off the bat that we don't have to do like any extra work for? The vertex. It can also give you the what without having to do any extra work for it. The axis of symmetry. All right. What about standard form? What does that give you right off the bat? The y-intercept. Good. So when we're looking at the vertex form, so our vertex form function, and remember, this would be the same thing as a times x minus h squared plus k, where the vertex is the point hk. All right. Now, I want to do one where you have a dilation with it because I want to show you guys the pattern and like an easier way to do it, because I conferred with Miss Melby yesterday and I remembered the easier way to do it because apparently yesterday my brain just said no. So first off, let's just go through these. Does it open up or down? What do you guys think? Down. Why? A is negative. Good. Since that A is negative, we're opening down. So we're going to skip some stuff and come back to it. So does that mean we're going to have a max or a min? A max. So based off of that, what's my vertex? 2, -1. Why is it not -2, -1? Right, because in the part right here, remember, since the minus is part of the original formula, that means that the number next to it, or the h value, is technically positive. Now, if it was positive within the parentheses, that means it's a negative number because a negative times a negative gives us a positive. Okay? Now, we'll come back to y-intercept and everything. So what's my a value here? -2. What about transformations? Can someone name me one transformation? By what? So not by -2, it's only 2. All right, so the negative deals with the reflection side of it. So we know it's a dilation. Does anyone remember the special phrase that I used to describe it? Ashlyn? Good. So this is a vertical stretch by 2, or a scale factor of 2, but I just don't want to write the word scale factor. Does anyone remember what happens to the graph if you're doing a vertical stretch? It gets thinner. Good. So remember the rubber band yesterday? If you pull it vertically, it gets thinner. If you compress it or push it inwards, it gets wider. Now, it will compress if you have a what?
It's between 0 and 1.
A number between 0 and 1, which in other words, that's a what? It's a fraction, all right? So it's a true fraction, meaning the numerator is smaller than the denominator, because 3/2 is technically a fraction. It's an improper fraction, though, because 3/2 is the same thing as 1.5. Still greater than 1, still would give us a vertical stretch. What's another transformation? So we got the vertical stretch. What else will this graph do? Audrey. Yes, reflection over the x-axis. And that's just a fancy way of saying it's just going to turn upside down. What's another transformation? Ashlyn. Right 2, good. And then there's one more. Someone else who hasn't talked yet. Lizzie. Down 1, good. Now, what are these transformations going to be made in reference to? So what would my pre-image be? So what would my starting image be? The parent function, good. And what is the parent function of a quadratic? X squared, good. All right, now, here's the part that I want to talk to you guys about. Okay, so there are 2 ways of graphing it. All right, some people like me are a table person, okay, where you just make a table, get some values. But other people are a pattern person. So I'm going to first make a table, and then we're going to kind of compare when I show you how to do the pattern. Okay? So if I make a table, all right, you always want your vertex to be kind of in your middle. All right, because remember that's the turning point. It's like the very bottom, and it also shows you where you're changing direction. So where you go from decreasing to increasing or vice versa. Now, what I typically do is I just do the same distance above and below the x value. All right. So for example, I'm going to go 1 above 2. So I'm just going to add 1 to 2, which is 3. And then I'm going to go 1 below 2, so 1. Why do you think I do that? They'll be the same what? They'll be the same y value. Why? What's special about quadratic? They're symmetrical. Good. So if they're the same distance from the vertex, they're symmetrical. All right. So I only have to put in one of these numbers. So I'm going to put in 3 so I have some positives. So what's 3 minus 2? 1. What's 1 squared? 1. What's negative 2 times 1? Negative 2. And then subtract 1 from that. Negative 3. So this would be negative 3. And what would x equals 1 be? Also negative 3 because it's symmetrical. Now, I typically want at least 5 points. So I'm going to do another one. So I'm now going to do a distance of 2 from the vertex. So I'm going to subtract 2. And then I'm going to add 2 to 2. So this will be 4. All right. So I'm going to put 4 in for x in my function. So what's 4 minus 2? 2. All right. What's 2 squared? 4 times negative 2? Minus 1. Negative 9. So here and here. Now, we can then graph those points, but I'm going to hold off on graphing it for right now because now I want to show you the pattern way. So the pattern way is very, very similar to doing rise over run with a linear function. Okay? So the way the pattern way works is first off, you got to figure out what the pattern is in reference to the parent function. So the pattern is that x squared now becomes whatever our dilation is, so negative 2x squared. So whatever is being multiplied outside. Now, what this means is if I plot my vertex, all right, you always start by going 1 out from the vertex. So 1x on either side from the vertex. Then, to figure out the y value, what you would do is You'll take that x value and you'll square it and then multiply it by -2. All right. So to figure that out, you would do -2x squared. So whatever that x value is when you go out 1, that's what you would do. And that's what you would go down. Now, that may not make sense, but let's put it in action. So first things first, I'm just going to graph the vertex. So that's 2, -1. Now, I'm going to go out 1 on either side. So I'm dealing with x is 1 and x is 3. Now, we know what those values are already from our table. Okay? So now we're just going to kind of confirm that. So we're going to use our table as kind of our check. Okay? Now, we first need to square the x value that we're trying to find. So if we're looking for when x is 1, what's 1 squared? 1. All right. And then times -2. -2. So that means my y value when x is 1, we would go down 2 from where our vertex currently is. All right. So that's what it tells you. This will tell you after you square it how many units up or down from the vertex y value. And that's how you do it, by squaring the value that you did or how far away you are from, and then going that value down. So we're still 1 unit away. So this will be what you plug into x. Depends on how far away you are. All right. So however far away you are horizontally from the vertex, you square it and then multiply it by the scale factor. And that'll tell you how far down or up from the vertex you need to be. Okay. So for 3, it should be the same thing because they're symmetrical. Which it is. It's 1 away from the vertex. Squared, it's 1 times -2. You're going down 2 units. Now, let's say we're going 2 out. So let's say I'm going to the right. Okay, so I'm 2 units out. So I'm going to first start by squaring that 2. So what's 2 squared? 4 times -2. -8. So I'm going to count 8 units from this current y value. So where the vertex is. So 1, 2, 3, 4, 5, 6, 7, 8. So my point will go right here at 4, -9. Is that where it's supposed to be? Yes. And then we find its symmetric buddy at 0. Does that kind of make a bit of sense how that works? So now, if this doesn't make sense to you, make a table. All right. But if the pattern is where you like to go, that's fine as well. Okay. So again, I'm more of a table person, but it's to each their own. Okay. If you like the pattern, do the pattern. If you like a table, do a table. I don't care as long as the graph gets graphed and it's graphed correctly. Okay. So let's finish this up. So the y-intercept. All right. So we already found the y-intercept. What is it? 0, -9. Now, domain. What's always my domain of a quadratic? All real numbers. So I'm going to do my shorthand. What's my range? -infinity to -1, and we put a bracket with the -1. All right, any questions on this? Does anyone want to see me do the pattern method one more time? Just so y'all can see what it is. Uh-huh. Oh, of course. 100%. So, guys, all real numbers, I don't care if you do the R with a line through it. I don't care if you write out all real numbers. I don't care if you do from negative infinity to positive infinity. That all means exactly the same thing. They're synonymous.
Are you comparing it to this one?
No. So remember, we're comparing it to x squared. So remember the very first thing we did at like the top of page 25, I think it was. No, 24. So remember, this is the parent function. And so everything we do is in terms of that parent function. So when we broke it down yesterday, where is it? All right. Typically, and we'll go more in depth with this when we get to our functions unit. But if you're multiplying, that's typically your dilation. If it's negative, that means you have a reflection over x. If you are, whatever you're adding or subtracting inside, that's your left, right. And whatever you're adding or subtracting outside the parentheses, that's your up, down. Does that kind of make a bit more sense?
Is it always going to be, are we always going to compare it no matter what?
Yep.
To that parent function?
That's why it's called the parent function. It's always the original. Any other quadratic is a child of x squared. And you're just trying to find its the similarities and the differences. All right. Any other questions on that? Again, does anyone want to see me do the pattern one more time? Are we good? Okay. So now let's finish up what we had to do yesterday. So turn to page 26. Let's finish this very quickly. Okay. So now that we know all about how vertex form works, we're now going to actually write out equations if we're given the vertex and then use another point on the graph to find the A value. All right. So let's look at letter A. So they gave me my vertex as 4, 3. Now, they did not tell us what the A value is. So for right now, we're going to start with y equals A. All right. Someone raise their hand and finish the rest. So we know we would have x. Then what would I put? Minus h. So minus what? 4, because that's my x value. All squared. And then what goes on the outside? Plus k, which is 3. All right. So that's my kind of unfinished vertex form for this function. Now, to finish it, we're going to use this point to find our A value. How do you think I'm going to do that? Plug it in for what? Plug it in for x and y and do what? Solve for A. So we're going to plug 5 in for x and 5 in for y and then solve for A. So I have 5 is equal to A times 5 minus 4 squared plus 3. All right, now we're going to do some simplification before we start moving things around the equal sign. So what's 5 minus 4? 1. It's 1 squared? 1. So I have 5 is equal to A, because 1 times A is just A, plus 3. So what's the only thing I got to do to solve for A? Subtract the 3. So 2 is equal to A. No, because what this will look like is this would be A times 1 plus 3, and by order of operations, you do the multiplication first. So if I rewrite my function with my A value, you have y is equal to 2 times x minus 4 squared plus 3. And we don't have to do any other simplifying besides that because I want it in vertex form. All right, any questions on that one? Do I need to do letter B, or are you guys pretty good? Do you want me to do letter B? Yes? Okay. All right, first off, let's get our unfinished vertex form. So what would that be? Someone raise their hand, tell me what they think it would be. Claire.
Y equals A parentheses X plus 2.
Uh-huh.
And then close parentheses squared plus 5.
Good. All right, so that's our unfinished vertex form given this vertex. All right. Now, just like we did, I'm going to take my x and y and plug them in to their respective spots and solve for a. So I have 1 is equal to a times 0 plus 2 all squared plus 5. So let's do some simplifying before we start moving things around the axis. Or not around the axis, around the equal sign. So what's 0 plus 2? 2. And what's the square of that? 4. So this will be 1 is equal to 4a, because we're doing a times that number, plus 5. Now we got a two-step equation, so what do I do to solve? Subtract 5 to both sides. I get negative 4 is equal to 4a. What's the last step? Divide by 4. So a is equal to negative 1. So if I rewrite my function, it'll be y is equal to... Now, we don't have to actually write out negative 1. We can just put a negative sign outside the parentheses. It's the same thing. So negative x plus 2 squared plus 5. So if you're ever given a problem where you got to put it into vertex form and they give you the vertex and a point, you need to find the a value using that point. So get the unfinished version of the vertex form first, plug the point in, solve for a, rewrite it with your a value. Any questions? All right. Now, let's look at this when we're given a graph. All right. So just from looking at this graph, what can we already assume? The a is negative, and we can already assume the vertex. So we got the vertex here, and we know we're going to have a negative a because the graph is opening downward. So my vertex is at the point 0, 2. So what would my vertex form look like? My unfinished. Because we don't know what our a value is yet. So let's just put our x values in as is, okay? Don't worry about the 0 right now. So I would have y is equal to a times x minus 0 squared plus 2, okay? Now, we can do a little bit more simplifying. Because what's x minus 0? X. It would be negative a. I just didn't put the negative. Now, since x minus 0 is just x, and if we square that x, it's x squared, we can write it like this. So if you do not see parentheses with something being added or subtracted from the x, it's 0. Okay? So it's the same thing if you saw, let's say it was like this, a of x minus 2 squared, and that's all they wrote. You would assume the y is 0. Okay? Yes? Yes, but since you guys are honors, get used to simplifying. Now, if you wrote that before you simplified to like kind of remind yourself, that's totally fine. But yeah, I would definitely simplify it at the very least. All right. Now, there's two ways that we can find the a value. The first way is to just get a nice happy point on the graph and plug that in like we've been doing. All right. And the other way is to use the pattern method like I showed you. So I'm going to use the pattern method first. So I have a happy point right here at -1, 0. So I'm going to look to see how far out I went and then how far down I went. Okay? Because remember, we would square how far out we went and then multiply it by whatever our scale factor is, and that'll give us how far down we go. So from 2, or from y equals 0, all right, not y equals 0, x equals 0, geez. I'm 1 away from that to get to -1. So I go 1 unit over. How many units did I go down? 2. So let's think about this logically. We know we have to square this 1. So what's 1 squared equal to? It's equal to 1. Now, what times 1 would give me 2? 2. So our scale factor is going to be 2, but it's the negative version of 2 because we're going down. All right. So we can assume that this is y is equal to -2 x squared plus 2. Now, we're going to use that same point and do it the other method just to check ourselves. So we're going to plug in -1, 0 in for x and y and solve for a. So if we plug it in, I have 0 for y, and then, now guys, this is where you don't want to write the negative with your a value, okay? Just for the sheer fact that it'll divide the negative out and you'll get the wrong scale factor. So there's 2 different ways that you can do this. You can keep the negative and just know that when you put it back in, the a still needs to remain negative. Or you can leave it without the negative, knowing that it has to be negative, and when you solve for a, it should give you a negative answer. Okay? So if I do that, I have negative a times 1 squared, or -1 squared, plus 2. What's -1 squared? 1. So this would be 0 is equal to negative a plus 2. Subtract 2 to both sides, I get -2 is equal to negative a. Divide by the -1. A is equal to 2. But remember, I'm plugging it back into this version of the function where it's already negative. So I just got to remember to put the negative on there. Now, if I did it without the negative, so I started with y is equal to ax squared plus 2. All right, and I plug that point in, so 0 is equal to a times -1 squared plus 2. 0 is equal to negative a, not negative, positive a plus 2. So -2 is equal to a. You would still get the same scale factor. You just would not have to remember that it needs to be negative. Does that make sense? Either way, you would still get this. All right, last thing, at least for this part of the lesson. Then we're going to do an activity together before I give you the quiz. All right, so, because the quiz is really quick, guys. It's only like 6 questions. So, the last thing we're going to do is convert from vertex form to standard form. All right, so we're starting in vertex form and we're converting to standard form. So remember, standard form is what? Right, ax squared plus bx plus c. That's what we're converting it to. So, first off, we got to do some expanding. So if I look at letter A, we are not going to start by distributing. And we can't distribute that negative right off the bat because we got that square there. Okay, so since x plus 3 is all squared, we have to not distribute right off the bat. or we cannot distribute right off the bat. Now, what's x plus 3 squared the same thing as? How could I write that out if I expanded it? Nope. X plus 3 times x plus 3. So this is the same thing as negative x plus 3 times x plus 3. Now, we know how to take care of that. What do? Either do a box method or you do FOIL. All right? So I'm going to do a very quick box because I know you guys know how to do box method. No, I don't distribute yet. Always distribute at the end. So we're going to take care of that negative at the end. That's the last thing we're going to do. All right? So this will be x squared, 3x, 3x, 9. Add my like terms. I have negative times x squared plus 6x plus 9. And then the last thing I do is distribute the negative to everything. So y would equal negative x squared minus 6x minus 9. And that's our standard form. All right. Now, let's try letter B. So I'm going to go ahead and rewrite it, expanding the x minus 1 squared. All right, so whenever you have to convert from vertex form to standard form, that should be the first thing you start with to remind yourselves that you don't just square the x and the negative 1. All right, if you just do that, you're missing the middle term or the x value. So this is the same thing as 2 times x minus 1 times x minus 1 plus 5. Now, I'm going to tell you the steps for this. So we would evaluate this first. That's the first thing we do. Then we distribute the 2. That's the second thing we do. And then lastly, we add the 5. So adding the 5 should be the very last thing you do. And you'll see why in just a second. So first things first, I'm just going to do a quick box method. Now, I'm not going to do a box because that's also a very easy FOIL. X times x is x squared. Negative 1 times x is negative x. There's 2 of them, so that's negative 2x. Negative 1 times negative 1 is negative 1. So this will be 2 times x squared minus 2x plus 1. And then make sure you bring down that plus 5. Now, do you guys see why I would distribute next before I add the 5? Yes, because it's only connected to this set of parentheses. So this will be 2x squared minus 4x plus 2, and bring down the plus 5. And then the last thing I got to do is combine those last little like terms. So this will be y equals 2x squared minus 4x plus 7. All right, any questions on this? Okay, so for homework tonight, never mind. I don't like what that's down there. I know you guys already know how to do that. Okay, so here's what we're going to do next. So what we're going to do next is learn a new skill. All right, and we're going to do this for about 30 minutes, and then I'll give you guys the quiz at around 9 o'clock, 9:05. All right, so watch the clock. If I do not stop by then, stop me. Okay? So what we're going to do now is we're going to do an activity that will teach us how to complete the square. Now, why is this important? This is important because we know how to go from vertex form to standard form. But now we need to learn how to go in the opposite direction. So from standard form to vertex form. Now, the only way to do that is through a method called completing the square. All right. Now, before I actually teach you the algebraic method, I want to actually look at it through a geometric standpoint using algebra tiles. All right, so we're going to use online algebra tiles, and I'll explain all of that works in a second. So, what I want you guys to do first is take out your Chromebooks and log on to Canvas. So while you guys are doing that, I want to pass something out to each of your groups. So I'm passing out only one worksheet to your groups. So you guys are going to work together as a group, and you're going to write your answers on the sheet. Now, when you get to Canvas, where I want you to go is, I want you guys to go to my modules. So go to modules, scroll all the way down to unit 3, and click on where it says completing the square activity. So this should pop up. It should look similar to what's on your worksheet. I literally just kind of screen copied it. So modules, scroll down to unit 3. So it's at the very bottom, and the last kind of page on the module says completing the square activity and today's date. That's what you need to click on. All right. So before we get into all the algebra tiles and stuff, what I want you guys to do is with your group and on your paper, so dictate one person as your scribe. All right. I want you guys to work together and do the area model multiplication. So just to recap, area model multiplication is basically box method. So whatever's on this side, you multiply it to this column, and so on and so forth, and then you add it all together at the end. All right? So go ahead and complete these first 3 on your sheet, and then stop. I'm going to give you guys 5 minutes. It's not hard. And no calculators. So talk about the other group. Someone needs to scribe. So it's on your sheet, it's the exact same thing as on Canvas. Only one person needs to write out, but you can talk about it together. No calculator. All the stuff you guys can do by hand.
It might all be the same. Are 600 and then -40 and -60.
And by the way, guys, all 3 of these should give you the exact same answer because they're all representing 15 times 27. So do not work ahead. It's not necessarily in the negative area. We're not doing it out of the area. We're just doing it. They're basically saying that if you subtract 5 from 20, that's 15. How do you subtract 3 from 30? So it's like a. So just treat it as a box. And then you would add it. All right, time's up. All right, so let's talk about this. All right, so what should be our answer overall for all three of these? 405. So 15 times 27, if you did put in your calculator, is in fact 405. Now, this is a method that you can use instead of ye old-fashioned this way. All right? So, it's almost like breaking it apart in your tens and your ones place and then setting up a box method. Because if we look, what's 10 plus 5? What's 20 plus 7? We know 10 plus 5 is 15. What's 30 minus 3? 27. What's 20 minus 5? 30 minus 3? 27. So we're still doing 15 times 27. We just broke it apart into something easier because multiplying two numbers with zeros on the end is really easy. So all you do is multiply the very first numbers together. So 2 times 1, that's 10. Or 2 times 1 is 2. And then however many zeros are between the two, that's what you have at the end, 200. So what's 20 times 5? 100. 7 times 10 is 70. 7 times 5 is 35. And then you would add them together. 200 plus 100 is 300. Plus 70 is 370. Plus 35 is 405. If I do it over here, this is 300. This is 150. This is negative 30. And this is negative 15. So 300 times 150, not 300 times 150. 300 plus 150 is 450. Minus 30 is 420. Minus 15 is 405. Then the last one, this is 600. This is negative 150. This is negative 60. And this is positive 15. Because negative is negative. So 600 minus 150 is 450. Minus 60 is 390. Plus 15, 405. Is that what y'all got for these?
Yeah.
Now, why is this important? Because this leads into the algebra tile discussion. So, by raising hands, how many of you guys know what algebra tiles actually are? I didn't think so. So, the way I describe algebra tiles is, in Math 1, I use them to introduce factoring. All right? You can also use them for completing the square, combining like terms, all that stuff. Essentially what it does is that algebra tiles are very similar to base 10 blocks. So do you guys remember doing base 10 blocks in elementary school where like you get a big square and that's 100 and you get like a rectangle and that's 10 and then like a little one that's the ones? Same thing, except now your big square is x squared, your rectangle is x, and your little square is 1. All right. So scroll down and look at the next part. So if we're looking right here, so I embedded Polypad in the Canvas page, but you can also hit this blue cube and it'll open it in Polypad. But these are algebra tiles, okay? And below, they did x plus 3 all squared. Now, we know x plus 3 all squared is what? How do I expand x plus 3 squared?
Plus one, plus one, plus one.
Right, it's x plus 3 plus x plus 3. All right. Now, that answers your first part of the question. We're going to do this part together as a class. So write that down. Expand is x plus 3 times x plus 3. Now, if we factor this or FOIL this, so take a minute with your group, FOIL it, factor it, not factor it, FOIL it or box method it, what would you get? X squared plus 6x plus 9. Good. Now, here's the cool thing about algebra tiles. So, algebra tiles take an algebraic concept and turn it into a geometric concept. All right? So, in reality, we're using area here. All right? So, area of a rectangle, area of a square. So, what this looks like is, if it looks like this, all right? Okay? This is almost like a box method. Because, let's say I cut these off here. And the reason I did that is I wanted the x's to line up and the ones to line up. All right? So if I do x times x, what would that give me? Isn't that what I got here? How many ones do I have right here? 3. How many here? What's 3 times 3? Is that not how many ones I have here? Yes. What's x times 3? Is that not the number of x's I have here? All right. What's x times 3? Is that the number of x's I have right here? Yeah. So if I count everything in here into square, what is it? So I have an x squared. How many x's do I have total? 6 x's plus 9. So you guys see the correlation? So, like I said, algebra tiles take a geometric or an algebraic concept and make it a visual geometric concept. And all you got to do is know what area means. Because if you think about it, the length of the long side of the x is x. The length of here, long side is x. Whereas the length of the short side of the x rectangle is 1. Because x times 1 is x. X times x is x squared. 1 times 1 is 1. Now, this is called a perfect square trinomial. Why? What do you think? Why do you think this is called a perfect square trinomial? Because equal what? Well, this is the perfect square trinomial. Why is it called a perfect square trinomial? What did we start with? We started by squaring a binomial. So, if you're squaring a binomial, meaning you're multiplying it by itself, it will create what's called a perfect square trinomial. All right? Now, geometrically speaking, why do you think this is called a perfect square trinomial? It's a square. All right? The sides are equal. This side is x plus 3, this side is x plus 3. It created a square. All right? Because what's true about squares? All the sides are equal. If you look, this is x plus 3, x plus 3, x plus 3, x plus 3. They're all x plus 3. All right? So, what I want y'all to do next is, on your paper with your proof, all right, we are going to look through of all the functions listed below, all right, and you can answer number 3, what makes a quadratic a perfect square trinomial, all right, because we already answered that together. But what I want you guys to do is, of all 6 of these, figure out which ones are considered perfect square trinomials. Now, a way that you can use this is that you can also do this with the algebra tiles. So what you can do is, if you hit this blue thing and open link in the new tab, you'll see this. Now, you can add on whatever you need to do. So let's say, for example, we did the first one together. So let's say we did 8x squared plus 8x plus 12. All right. Now, I'm going to add to this square. So what you're going to hit is that you'll go to algebra, hit algebra tiles, and there's all your algebra tiles. Now, if it's negative, use the red. Okay, just so you know that a negative times a negative, or just so you know that something negative is negative. All right, so use the red if it's negative. If it's positive, use the other colors. So I'm going to add on. So I need 8x, so I'm going to add on 2 more x's to this. So I'm going to add on 1 more x on this side and 1 more x to this side because I want it to be symmetrical. All right. Then I'm going to add on a 12. So if I add on 12 here, what am I doing? I'm hitting the wrong one. So if I add on 12, I already have 9, so I just need to add 3 more ones. So I'm going to put them right here. Now, just from looking at it, all right, I could add another one out here because that would give us this row. So we know that x times 1 gives us this x. But my conundrum is that I can't make it an even side because there's nothing here. And we can't manipulate it so that it is. All right? So would this be a perfect square trinomial? No. All right? So we know that number 1 is not a perfect square trinomial. So what I suggest you guys do is split the other 5 in half between your group. All right? So like one of y'all do 2, the other one does 2, and the other one does 1. All right? And figure out if it's a perfect square trinomial or not. All right? And you can use the polypad. Just so you guys know, if you need to delete any, all you would do is click on it, hit the trash can. All right? If you need to make it negative and you already have it positive, you can just hit negate and it'll make it negative. Hit negate again, it'll make it positive. And you can also, if you've oriented it the wrong way, you can also grab it and turn it. So I'm going to give you guys about, let's go. Yeah, let's say 10. Okay, so let's do 10 minutes. Yes. Okay, so all you gotta do is drag and drop and do whatever you need. So what are you doing? Okay, so X squared plus 10x. So you got 5. Yes, you're about 10x. 0 got 2x. Now you just need to fill in 1. Your goal is to fill in. Right. So how many ones have current? I need to add one more. Internet, see those? So your goal is to line it up so that it looks like a nice split. Where if you so like what I have right now, that's right. Right, because the sides are not even. So you want to be able to back it. X plus 5 on one side and X plus 5 on the other. Now, since this is what's your change?
On your negative, it was X plus 3.
Yep. So negate means space. No. All right, guys. So everyone is working on this.
You already had one. You didn't have small.
Then we're gonna tell Ella. Yes, you do.
I'm sure more than enough. Oh, David, I was like, I would have said yes. X plus 3 squared. You stole it. You expanded. I had to snap it back. Number 2.
We saw you like.
How do we explain the X squared? Wait, how do you know if there's something going from it? So what are the 6?
So remember, even if you get to line up, make sure that if you looked at the lengths of each side, that it would not be a rectangle. You want it to be the same length on each side. So for example, guys, look up here. Look up here. Is this a rectangle or a square?
Right.
Why? They're different. So if I take the side length, this side length is X. This side length is all ones. There's 4 ones. So X plus 4 is on this side. This side length is X. This side length is 1, but there's only 3 of them, so X plus 3. So remember, even though it may line up perfectly, but it's not necessarily a square unless both sides are equal. Okay, so it's under. No. But so this is. I mean, it was.
Why am I seeing so much?
Just make sure.
I would use
No.
right. I could do with the air.
What do you?
That's right. I think
there'd be 9x. So if you can't split them evenly, then probably. Because that's rule 1. All right, guys. So it looks like most of y'all are wrapping up. So let's go ahead and talk. All right. So in terms of a thumbs up, all right, thumb up being yes, thumb down being no. Is number 2 a perfect square trinomial? Yes, it is. All right. What would the side lengths be? X plus 5. All right. So you can rewrite this as x plus 5 squared. Is number 3 a perfect square trinomial? Yes, it is. You can rewrite it as x minus 2 squared. What about 4? No, because of that 9x right there. There's no way you could put even number of x's on each side. All right. What about 5? Yes or no? Yes. So this is the same thing. Actually, no, you cannot. There's that negative right there. All right. So if I factor this, guys, this would be, I need 2 numbers. I multiply to 36 but add to negative 12. So that means I have a positive and a negative number. So it would be not the 6's. If I put 6 here, 6 here, they cancel each other out. All right. So in other words, you can't have the same numbers. All right. So that's not a perfect square trinomial. What about this one? Yeah, it is. You can make this as x minus 3 all squared. So guys, I would write this down on your paper, but the formula for a perfect square trinomial is that if you have x plus or minus some number, let's call it a, and it's all squared. This is the same thing as x squared plus or minus 2ax, so whatever 2 times a is, and then stop on the x, and then you keep the sign that's originally with it, plus a squared. All right, so that's why this one is incorrect, because it has that minus. The only way you can square something, and it'll give you a negative number. All right, so we're going to stop here for today, because I want you guys to have enough time for your quiz. So what I think I'm going to do is that tomorrow I will have you guys kind of finish up this activity on your own. And then in my video, because I'll probably make a video as well, I will have an explanation video for this. All right, so if you get stuck, you can go and look at the video. All right, but let me just do a quick explanation, because you guys are going to have to explain this to, your group mates that are not here. So essentially what the next part is that you would have to rearrange these to make it look like a square. So you have an even number of x's on the sides, and then you'll have the ones. All right, and it's going to ask you, do you have any ones left over? Do you have any extra ones? All right, or are you missing ones? And how many would you need? All right, that's what it's asking. Then what you would do is write out what the equations would be as you have them currently, and think about what you could do mathematically to make it work. All right. So then you would answer the rest of these questions right here, and they'll kind of explain what's going on. So again, make sure all of your group members' names are on it. All right. Either one of you can hold on to it, or if you want, you can put it in the box and then grab it tomorrow. Okay? But make sure you guys' group's names are on it. So this is what you're going to pick up with tomorrow. And again, I will have an explanation video for this. So if you get stuck, look at my video. All right? Huh? The what?
Our third grouping celebration.
Yeah, come on.
It's a huge girl. I did see my soccer coach 3 times.
All right, guys. So here's what we're gonna do. I need you guys to clear off your desk with everything except for to write with.
I totally didn't see mine.
You know what? Free night, you guys don't have homework. You're welcome. Oh, I got journal. So you can work on your journal. All right, so I need all computers put away. So I am going to be nice to you guys. And here's how I'm going to be nice. This is a group quiz. All right. So what that means is that you'll put the name. I want to give you guys one quiz per group. You're going to put the name of everyone sitting at your group currently. All right. If they're not here, don't put their name. I'll have to make it up later. All right. Now, one person needs to be your scribe. All right. So one person needs to do the writing, or you can switch off. It doesn't matter. But you need to talk with your group about all these questions and work together to get the answer. So not one person should be doing all the work. If one person does all the work, that person's going to only get the credit. All right? So everyone needs to contribute. Now, if you want to have a whiteboard and a marker or a scrap sheet of paper so you can work stuff out, like so you don't have to like go all over the paper, that's fine. Just as long as your final work gets transferred to the paper. All right? Now, number 1 is the only question that is not multiple choice. All the other ones are multiple choice. All right? And no calculator. So I will repeat, no calculators. All of this is calculator inactive, and the numbers are small enough that you can do them without a calculator. All right, so guys, hush. So, any questions on what I'm expecting of you guys to do? Now, here's the one rule. Guys, stop talking. Here's the one rule. You can only talk to people in your group. You cannot talk to other people in other groups. Okay? So you cannot like lean over to the group next to you and be like, yo, what's the answer number 2? No, you can't do that. All right? You can talk to the person in your group, and that's it. All right? Any questions? So again, make sure both of your names are on it, and when you finish, hand it to me. It's front and back. Let's make sure everyone's name is on it. When you finish, turn it to me. So keep it down so the people next to you don't hear. All right? So you guys got till the end of class. You got a solid 15 minutes.